Okay, so let's get back to it with the graphics part. So first of all, I want to just show you a very good resource, which is the website docs.gl. This is where you will find a well-presented documentation for every single OpenGL function call. So if you ever wonder what the parameters do, what parameters you need, or if they should be in bytes or if they should just be a size without bytes, you can look it up here. So if you just type GL, for example, create buffers, you want to find a documentation for all versions of GL. So for example, ES3, ES2, GL2, 3, and 4. This one is just available in 4, but if we were to go, for example, GL gen buffers, you can click on the version of OpenGL you're working with, basically. So, and what that will show you, when you click it, you can see what parameters it takes, exactly what it does, what OpenGL versions it's supported in, what possible errors it can return. And here you get all of the other functions as well. So if you ever need to look up a function or figure out what the parameters do it here. I use this one a lot when I did the course, and it's very helpful for a lot of things. So for example, same with buffer data. You can see that there are two forums, just regular one and a named one that we briefly mentioned last before the break. And so here you can see the target, and these are all the valid targets you can find it to or read from. So you have the array buffer, which is the one we've used, only one that's been used so far. Size says size in bytes of the buffer object, and data says a pointer to the data that will be copied there. And usage, there you have stream draw, stream read, static draw, dynamic draw, and here you can just see an explanation for what they mean. So for example, static, it will be modified once and used many times. Dynamic is like it will be modified repeatedly and used many times. And you can see draw, read, and copy. So it's a great resource for just looking up the calls to figure out the parameters and what everything does. So there are some of these also have a lot of example codes, so you can see this is how we use it. But yeah, I recommend this resource as the OpenGL documentation, as the official one is a little bit harder to navigate. And if you're even wondering how you can do something, you might also just guess the name. Like for example, if you type texture, maybe you figure out all of the texture functions. Or if you type buffer, maybe you find out all of the buffer functions, and you can just look for what you need if you don't know exactly what it's called as well. Apart from that, I'm going to show you how to use one graphics debugging tool and briefly mention a few others that exist. So the one we are going to show is called RenderDoc, and it's a very nice tool to be able to visualize. You can see all of your shaders, you can see all of the contents of your buffer, see have everything copied over correctly, you can see what buffers hold what data, and you can see how they're linked together. And you can also see all of your textures, you can see all of your draw calls and see if anything went wrong. Once you get to shaders, you'll also see what the shader parameters are set to, and you can see, you can basically look through all of the data that's been passed over to the GPU from the GPU's point of view. So it's a really great debugging tool, and we're going to look at how to use it afterwards, so I won't talk too much about it now. Another one is NVIDIA's tool, which is a little bit more complicated, and I don't know, I think it runs on Linux as well, but I'm not sure. It definitely runs on Windows, and it's integrated into Visual Studio with a plugin. And what that does is it allows you to, you can basically see how much time did it spend in the vertex shader, the fragment shader, how much time did it spend on this GPU, on the CPU, and you can get all of the draw call data. It's basically as much of a debugger as it is a profiler, so you can figure out which shader is the slowest shader. You can look at all of the caches and how data is flowing through them. It's a bit overkill, you probably won't need it, but if you want to look into it and have fun and see what it can do for you, then feel free to look into it. And yeah, you can see how pixel values change over time and on separate frames, and it's definitely one of the more advanced tools. Definitely works on NVIDIA cards. I but I'm not sure if it works on AMD or Intel, but definitely works on NVIDIA. I haven't tried it on anything else, but you'll probably find it. Anyway, and then the second one is one from AMD, which is similar, just it runs it runs on AMD for sure, but also I think this one works more on everything. Yeah, but it works best on AMD cards. So if you're using AMD, you should use CodeXL is a good alternative. It does basically the same, where you can see how functions work and how cards, how like the different shaders execute. You can analyze them, and yeah. So those are basically 3 different options that you can look into. But RenderDoc is probably going to be the most useful, the easiest to set up, and the easiest to use for this course, and it's going to be very helpful. So we are going to look into that in a moment. But first, we have to go in and look at a little bit of code. So all of this is basically setting up a couple of buffers to draw not a triangle. We're drawing a quad here, so twice as many vertices as a triangle. So let's start by seeing if we can see it. Is there a triangle here? Maybe. How would you change it? How would you figure it out? So if we go and change the background color to something else. Oh, there's a triangle. That's just to prove a point that if the triangle is black, you won't see it if there's a black background. So at least try to, if something's not working, try to change the background color first, because it might actually be there. We're just not going to go with the completely obnoxious color, but something in between, so we can, no, that's not enough. Just so we can see if there's something black on the screen. Yeah, so you don't have to go crazy green, but as long as it's you can discern the differences in the black. So yes, there's a triangle here. But as I mentioned, this is supposed to be a quad. So we have one vertex at the bottom left corner, one at the top left, one at the top right, and one at the bottom right. And then we have something that has not been discussed yet, but we have something called indices, which you can use together with the vertex buffer to basically say first render the zeros one, which is this one, then render the first one, which is this one, second one, which is this one, and then that becomes a triangle. And then render the second one, which is this one, the third one, which is this one, and the zeroth one, which is this one. So that basically means together that creates, well, maybe it would be nice to have the whiteboard marker now.
Yeah, I can get you.
Well, this is a whiteboard marker, right? No, this is.
This should be fresh, I think.
Yes, nice. Just to make it clear. So in this case, the first vertex, -5 is here. And then there's the top left one, the top right one, and the bottom right one. So basically what these vertices combined with the indices do is they say, draw the triangle composing of 0, 1, 2. So that's 0, 1, 2. And then do the triangle 2, 3, 0, which is 2, 3, 0. And that basically draws everything. But, and the way it, so what's the purpose of this? Basically now in the vertex list, we only have to have 4 vertices in there. We don't have to specify, don't have to duplicate this one, for example, because if we didn't use the list, we would have to specify this one, and this one, and then this one again, this one, and this one again. So you use indices to not duplicate data in here, because storing 2 or 3 coordinates takes a lot more memory than storing a single integer. Or in this case, just an unsigned character, which is just 1 byte. Whereas these values would be 8 bytes of extra data. So, and it's more obvious for a quad that it actually has just 4 points instead of 6 points, because you just have 4 corners, and then you just connect the dots with the indices. So it's draw a triangle between these 3 and these 3. So we could change the order here as well, and it wouldn't make a difference. If we change the order like this, it would just draw the other triangle first. So that's a brief introduction to indices for now, just so you know what's going on. And then we create two buffers. So we use create buffers and create two buffers into this array of two buffers. We fill the buffers with data. So you could use GLBuffer data here as well. I'm just using storage here for two reasons. One is to just show you that there are multiple functions that do the same thing, but they don't do the same thing, otherwise they wouldn't exist. So storage is one that came later in like 4. Well, this is what we have this one for. It's only available in 4.4 and 5. So it's a newer one. Basically the difference between them is that buffer data creates mutable storage and buffer storage creates immutable storage, so you can't change the size of it afterwards, which is possibly more performance, but it depends on the compiler. But so in this case, since we know we're never going to change it, I use this one, and it's also to show you that there are multiple functions to do the same thing, well, more or less the same thing. Then we create one vertex array. We have some global variable to store it in, just to not clutter up this space. It's basically just here, it's just a context that holds the program and the DAO and the DBO. It doesn't matter in this case. So we create a vertex array, which you were taught about on Tuesday. And then we say that the vertex buffer associated with this vertex array should be the first buffer, should be its vertex buffer, and its index buffer, which is the same as its element buffer. It's called index buffer and element buffer interchangeably. So you'll hear both terms, but they mean the same thing. So it basically just means the indices. And we say that this vertex array should use this index buffer. So now it remembers that state. These are also functions that come in later versions of OpenGL. So before, earlier you would usually bind buffers, like buffers of 0 to the array buffer slot. And you would bind the other one to the element array buffer slot. And use them like this. But, again, it's just showing that there are multiple ways to do it, and some of them are newer, more recent than others. So this, for example, might not work on older versions. Yeah, and then we're setting the vertex array attributes. We're using 3 separate functions here. You could have also used the one that you probably were shown, which is vertex attrib array or vertex attrib. Yeah, one of these functions.
Attrib pointer, I think it's.
What?
Attrib pointer, I think we.
Yeah, there it is. Yeah. So, but basically, this one is like doing these 3 operations in one call. So I'm doing the 3 one just to be very specific, and there are some other minorities, but again, just showing that there are multiple ways of doing it. So this is essentially saying that we have the 0th attribute is a 2-component float vector. So attribute 0 consists of 2 floats that should not be normalized, and we are binding this the first buffer with the first attribute. So you find the data for it in there. So basically, we just have one position attribute, and that's it. We just have a 2-component vector, so x and y position. That's all we have. And then we're just enabling it, which the other call will do for you as well. And then we bind the vertex array, and we just enable our shader, which we haven't talked about yet, but it's just basically we're just setting up a buffer which holds a quad, and associating it with the vertex array so we can draw it. And the main loop just clears and sets some shader variables and draws, just so we have something to look at. So, based on what we did before the break, let's look at something that may or may not. This is a quad. Actually, let's give it its colors back just quickly. So, why is Yeah.
PE
Yes, that's it's only drawing 3 of them, but we have definitely passed it 4 here and 6 in here. But we're only seeing 3 of them. So